So last time I asked you to solve the magic square, right? So here is the magic square. What was your strategy to solve this problem? Okay, so I want to hear your strategy. In problem solving, you must have a strategy, right? So we have 3 by 3 square here. And we know the rule. We're going to use 1 to 9, all the way to 9, only once. And the sum for each row and column and diagonal should be the same. So we are not given the sum, right? So without knowing the sum, how can we solve this? I gave you the hint, right? If I list this number 1, 2, 3, 4, 5, 6, 7, 8, 9. It's kind of balancing 1 and 9 together is 10, 2 and 8, 10, 3 and 7, 10, 4 and 6, 10, and 5 is alone. So how about you put that in the middle and kind of balancing, right? So if you want to put 1 here, where does 9 go? Opposite of that, either here or there or there. It doesn't matter, right? So where do you want to put 9? 1, 2, 3. Where? 1, 2, 3. Just pick 1. Here. 2. Here. 1, 2. 2 is here. So I'm going to put 9 here. And I'm going to see what the sum here is in diagonal. What is the sum? 15. So it seems like 15 is the sum. And then we can use 2 and 8. Now, where can I put 2 and 8? If I put 8 here, what happens? It's way too big for this one, right? So I cannot put 8 here. And I cannot put 8 here as well, because in this column, it doesn't make sense. So where could be the good number to put 8? If not here either, right? So either here or there could be 8, right? So where do you want to put 8? A or B? It's like I exam, A or B. A or B. Just pick any number. B here. So I'm going to put 8 here. Then where does 2 go? 2. The opposite of 8, right? So it will be right here. Because it makes 15 here. Right? Okay. Then we have 2 and 9. So what's the last number goes here in this column? 2 and 9 together is 11. You need 4. After that, it's getting easier. Where can we put up this number, right? What can we have? 10. Then something is wrong, right? So in that case, we can go back. So maybe that 2 and 8 is not good. So where else can 8 go?
On the other side of 5.
Here?
Yes.
Okay. So if I put 8 here, what goes here? 6. Okay. Then what goes here? Oh, 0. Something went wrong. What went wrong? Is there only places for 8? What if we put 9 in some other places? I think it should be the same. What if we put 1 and 9, not in the corner? Because in the corner, you have more options for 3 numbers. But if I put 1 and 9 here, will that be better? Can we try? So I'm going back. So 5. What if I put 1 and 9 here? Where can I put 8? I cannot put 8 here or there. definitely, right? So we have more options there. Where do we not put 8? Here?
Below 5.
Below 5. If I put 8 here, I can find what number goes here, which is 2. Then what else can we do? We can now think about 3 and 7, right? Right? Can 7 go here? No, because it's way too big, right? Can 7 go here? Not there, not there. How about 7 here? Not there either, because then it's 15. I have no number to put there. Then 7 goes only here. Okay, so kind of systematic. But let's see if that works. Then what goes here? 7, 5 together is 12. So I need 3. Then let's look at this part. 8 and 3, 11. And what goes here? 4. Then let's check if this is 15. Is it? No, it's not. So it went 9. So what do we need to change then? 8 place? Going backwards. What was your strategy after this? Where did you place the 8? So 8 doesn't go here.
With diagonal corners then.
Right here. Okay, if you put 8 here, what goes down here? This is 9. 6. How about here? Together 13. 2. Then what goes here? 7. We have anything wrong so far? I don't think so. Then what goes here by looking at this column? 4. Okay. How about this diagonal? It's 15. Oh, so it's fine. This is 15 and this is 15 and all of them is 15. What goes here? 3. So we use all of these numbers. Now let's check whether we have all the sum as 15. Let's look at this column. What is it? Sum of the column? 15. Okay, how about here? 15. How about this column? 15. How about the diagonal? 15. How about this row? 15. How about this row? How about this row? 15. How about this diagonal? It's also 15. So we found them. This is the answer, or this is a answer? Unanswer. It's unanswer, right? Yours should be different because you can, flip them around, right? If you flip it around, 4 goes on this corner, 9 goes here, 2 goes here, and so on and so on, right? So this is one of the answers that you can find. So we made some trial and errors there, but we had some strategies here too. So how did we start from? We thought 5 could be in the middle because that's the number in the middle, right? And we put 1 and 9 on the other ends, right? Because we know that 1 and 9 makes 10, 2 and 8 makes 10, so we can put 2 and 8 on the other end too, right? And so on and so on. So that was our strategy. Is that similar to your strategy? Is there anybody who had a different strategy to solve from?
I added up all of the numbers and then got 45 and divided it by 3. And then from there I found...
Why did you divide it by 3?
Because there's 3 rows.
That's really good strategy too, don't you think? So we can add all of them together using, I will just use the sigma, okay? That means you are adding from 1 to 9 If you add all of them together, that is 45, and divided by 3, because there are 3 rows or 3 columns, then you get 15. So you can find some could be 15. That's a good thinking. And then what did you do?
From there, I found combinations that equal 15, just 3 of them, and then rearrange them depending on if I can get the diagonals to match up.
I love that idea too. So were you able to find the numbers right away, or did you have some trial and error there too?
It took me a good chunk of time.
Yeah. How long did it take each of you?
I did the 1, 5, and 9,
Uh-huh.
and then after that I couldn't figure it out,
Uh-huh.
and then I realized 9 plus 5 plus 1 is 15,
Uh-huh.
and then I was like, okay, 15 has to do something, and
Okay.
then it took me a while until I figured out all of it was supposed to be 15.
Okay.
So
But that's still good thinking, starting from 1, 5, and 9, right? I like those ideas. Is there anybody else who wants to share your strategy? Very good. How did you solve it?
Well, I like to do Sudoku, so I did what she did and did a 1 row, and then I kind of just did the little ones in the corner, and then I just tested out what worked and what didn't.
Yeah, it's similar to Sudoku, except Sudoku you don't have to add. Yeah. Okay, that's good. Okay, I love that idea. Good. And I have only a few problems for you to solve. Can you read this, okay? Okay.
I'm so confused on this one.
Yeah, it is kind of
This
confusing.
one I was confused on when I did the homework. 'Cause
Yeah,
I did
that's
it
why I
5
brought it.
times.
Yeah, that's why I brought that
That's
solve
what I'm
together.
trying to do.
Yeah, I know. Okay, hold on. Let me see if I can copy this down. And actually, I want to open that on Jamboard. Oops, one more. Jamboard. Okay, and okay, so I can paste it. On Zoom, I cannot paste anything, so I like to do that. Okay, so let's look on this board. With a certain medical insurance policy, if you didn't solve this problem yet in the homework, maybe it's a good time to look at this together. Even if you solve the problem on the homework, maybe it was confusing a little bit, right? So let's read it together and solve it together. With a certain medical insurance policy, the customer must first pay an annual $150 deductible. So you have to pay $150 at the beginning. That's why you need to pay. So I'm gonna put that as something like cost. Is that okay? Cost is what I need to pay. 150. Okay. And then, but think about deductible. Deductible means you need to pay that money, but you're gonna get it back. But not exactly the same amount, depending on how much your medical expense is, right? Okay, and then the policy covers 70% of the cost of X-ray. And rest of them talking about X-rays, right? The first X-ray and second X-ray. So it's covering by insurance, but not 100%. Only 70% is covered. Then how much do I have to pay? If 70% is covered, I am responsible for 30%. So that's what I have to pay. So that's also included in my payment cost, right? I can say, and I need to pay 30% of whatever the expense is. Make sense? Okay. And the first insurance claims for a specific year submitted by a person are 2 X-rays. First X-ray cost $660. That's the X-ray cost. So X-ray cost goes up. And the second X-ray cost $900. However, we should not forget about the deductible. We need to get it back. So This is opposite of what you need to pay for because you're getting back. So it's opposite. We can put that as subtraction. Maybe that was where you were confused. So because this whole thing is what I need to pay, getting back should be the opposite of that. That's why I'm putting negative there. Does it make sense? Okay. So in the context, this whole thing is negative because it's what I have to pay for. And the deductible is what I need to pay back later. So this whole thing is negative. To make it positive to get it back, I need to put negative there. Negative, negative makes positive. Does it kind of make sense? Okay. So first deductible, you need to pay for it. But what you are getting back is only 30% of that much money. It's not fair, right? You don't get 100% of $150. Yeah, but that's our life. Always not fair. Okay, so these two are X-ray costs, but this is deductible. You need to take away. Then to solve this, 150 plus 30% is 30 per 100, right? 30%, 30 per 100. If we calculate 660 plus 900 minus 150, we can do this mentally. 660 minus 150 will be 510, right? So if you add 510 to 900, is it 1410, right? And this is 0.3 times, or I can do it this way. I think this is easier. Hold on. So before I multiply that by 0.3, I'm gonna cancel these two out by dividing both numerator and denominator by 10. Is it okay? And I still have 10 in the denominator, and I'm gonna divide 10 by numerator too. Is it okay? So we have 150 plus 3 times 141. And what's 3 times 141? 3 times 1 is 3, 3 times 4 is 12, 3 times 100, 300, so it's 423. If you add them together, you get 573. So that will be the cost that you have to pay. Make sense? Okay, so this is how you solve the problem. It is already open and it's still open, so you will be able to solve their problem. Okay, are we good? Okay. Let me give you another question from the homework. This one. Let me copy this. Here. It's not pasting. Like this. That's weird. Anyways, it says the ancient Greeks labeled certain numbers as triangular numbers. The numbers 1, 3, 6, 10, 15, 21, and so on are triangular numbers. And I have some questions here. So you need to determine the next two triangular numbers. So what we understand here is triangular numbers. Even if you don't know what triangular numbers, we kind of get some sense now. We can make triangle with the dots and count number of dots there. So in the first step, first phase, you have 1 dot. So it's 1. 1 is a triangular number. And you add how many more to that? 2. So we get 3. So for the first triangular number 1, we have 1 dot. For 3, the second triangular number, what we did is we are adding 2 to 1. right? And the next triangular number, we have 1 plus 2 plus 3. You see that pattern? It's 1 plus 2 plus 3. How about 10? How do we get that? How do we get that, Glenda? Plus 4 to the previous one. So 3 plus 4. The next number, we can add what to the previous number? 5. For the next number, we can add 6 to the previous number, and so on and so on and so on. So determine the next two triangular numbers. We can continue doing this, right? And find the sum. So after 21, what could be next number? I can add all this together plus what? 7. So previous number was 21. If I add 7 to that, I will get 28. That's next number. How about following number? I can add this whole thing by 8. So if you add 8 to 28, you will get 36, right? So these two are the next two triangular numbers. Okay? And it says, is 72 a triangular number? Explain how you determined your answer. I want you guys to think about this first. I will give you about 1 minute. Okay? And think about whether 72 is a triangular number or not. There shouldn't be only one way, you know that, right? So your solution should be different from others. Your thinking should be different from others. So I want to hear all various thinking process you guys have. Show me your thumb if you have an idea and solve it. Madison, what's your idea?
I said it's not triangular,
It's not triangular, why not?
so I just went through and kept doing the sequence.
Oh, so what's next one after 36? If you add 9 to that, 9 to
At
30,
45,
45, and you're gonna add 10 to that, 55, and then you're gonna add 11 to 55, 66, and then you add 12, 78. Can I stop now? Okay, so explain it. How did you determine 72 is not a triangular number?
because it wouldn't form a triangle.
Because it is not, it is between these two numbers, right? So it's not a triangular number. To be a triangular number, it has to be 66 or 78. But this number 72 is in between those two numbers, right? Very good strategy. Is there anybody else who has different strategy? Anybody? Nikki, you had the same idea?
Yeah, I did the same thing.
Okay. Caitlin? Same thing? Anybody else differently? Aubrey? Brenda? Gabriel? No? David? No? Everybody has the same idea? Okay. How about 120? You wanna continuously doing that? Is that a triangular number? What did you add to? So if you continuously do that, 78 plus 13, what do you get? 91 plus 14, 105. We're almost there. 105 plus 15, 120. So we found that, right? What if you are given really big number, like 2,000, 1,500? It's gonna be time consuming, right? So have you thought about finding a rule instead? That could be another idea too, right? So I want you to think about the rule by considering this. What I'm saying here is, I want you to consider each term with a triangular number. So we are given first term, okay? First term as one dot and one triangle. And second number is 1 plus 2. Third number is 1 plus 2 plus 3. Fourth number is 1 plus 2 plus 3 plus 4. And so on and so on. If I find 120th number, what would I add and up to one number? I would add what?
I would say we add up everything between 1 and 120.
Exactly. So you can see the last number that is added, and you can connect that with number of terms, right? So for first number, last number is 1, starting from 1 in consecutive 4 numbers, right? For the second number, from 1 to 2. Third number, from 1 to 3. Fourth number is add all the way from 1 to 4, and so on and so on. So we can see that, oh, I am adding all consecutive numbers up to 120 to find 120th number. But we can also find the rule to find the sum of the natural numbers like this, consecutive numbers. So let's think about that. If I have first number a sub 1, hey, do you guys remember about arithmetic sequence that we talked about? I sent you guys the video. Did you watch it? Did I send you the video? I thought I did. Let me check. I thought I sent you guys arithmetic sequence and geometric sequence video link. I didn't? Oh my goodness. I will send that again. Okay? Okay, then I will explain what's going on there. Okay, have you ever heard of arithmetic sequence? Can you talk about this in class, arithmetic sequence? When you're adding the same number continuously? We did, right? But we didn't talk about the geometric sequence in the classroom. So I made a video and I thought I shared with you, and apparently I didn't. I'm gonna send it today, okay? So arithmetic sequence is when you have first term and you keep adding the same number to the previous one. So, you know, the third term will be 2D because you're adding D more to that, and so on and so on. So if you are looking at this sequence, this is the first term, this is the second term, this is third term, and fourth term will be just D more to the first one, third one, D more to the third one. What do I get? 3D, right? Because I have 2D plus D, which is 3D. This term will be first term plus 3D plus another D, that makes 4D, right? So if we compare what's changing and what's staying there, a sub 1 is staying there. The sixth term will be a sub 1 plus. What's happening here is this is changing. What is multiplied to D? So for the fifth term, I have one less number multiplying that by D. For the fourth term, I have 3 times d, which is 1 less than the number of terms. Do you see the relationship there? Here I have 1d, which is 1 less than that. And here I have 0 times d. Because 0 times d is 0, I don't have to write it. But I can see that 0 is 1 less than 1, right? So this rule works for any number, right? So this is arithmetic sequence. When you have first term, a sub 1, and the difference, okay? And you can find any term. So this is for nth term. Thinking about that, in our number of sequence, what's the difference? 1, 2, 3, 4. It increases by 1. So the difference is 1. When you're looking at this sequence, for example, in this sequence, we know that the nth number, so I'm looking at this sequence, okay, 3, 4, dot, 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 dot. So the nth number will be a sub 1, which is 1 plus n minus 1 times. The difference here is 1 because we are adding 1 to each of these numbers. So the d is 1, right? And what's our first number? That is 1. So the last number, nth number, will be 1 plus n minus 1. So it is n. So it makes sense. The nth number is n, right? So that's the sequence here. Now I want you to think about the sum of the arithmetic sequence. So can I move forward here? So now I am talking about adding those numbers. 1 plus, 2 plus, 3 plus, 4 plus, all the way to n. What's number before n? 1 less than n. So n minus. What's 1 less than n?
N minus 1.
Yeah, n minus 1. It makes sense, right? This is what we're gonna find. And let's say that's sum of n, which means from 1 to all the way n. If I write this again, backwards, starting from n, and n minus 1, and so on and so on and so on, and I have 1, 2. Is that same as the first one? It's the same, right? Because we can use the commutative property in addition. What's happening here is, if I add these two together, what do I have here? How many SNs do I have? 2 of them, right? 2 sum of the numbers. And each column I can add them together. 1 plus n. What's this? 2 plus n minus 1. What's 2 plus n minus 1? 2 plus n minus 1. 2 minus 1 is 1. So I still have n plus 1, right? So the first column I have n plus 1. For the second column I have n plus 1. And the next number here, 1 less than that, should be n minus 2. So if I add 3 and n minus 2, what will I get? N plus 1 again, right? 3 minus 2 is 1, and n plus 1. And so on and so on. Here as well, n minus 1 plus 2. What's minus 1 plus 2? Plus 1, right? So I have n plus 1. And the last one is also n plus 1. Since repeated addition, how many of n plus 1 do I have? Can we count this? Yes, we can. We know there are 1, 2, 3, 4, dot, 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 n many, right? So there are n many n plus 1. There are n many. So the repeated addition, we can change that to multiplication. N times n plus 1. Are we good? That is 2 times s of n. Then the sum of the number should be, I can divide both by 2. divided by 2. N times n plus 1. That is sum of consecutive numbers for n term. Are you following me? Does this make sense? Show me your thumb if you got that. If you don't, please thumb down. Okay, thank you. So everybody understands what's going on. S of n means it's the sum of all the numbers from 1 to n. That is how you can find it. So the last number and add that by 1, multiply them together and divide it by 2. So going back here, we can plug that into any of them. So we know S of n, let me write that with red color. Here, S of n, so sum of all the consecutive numbers is n times n plus 1 divided by 2. Doing that, we can find the sums for any of the terms. For example, if we are finding the term here, the fourth number, S of 4, which means 1 plus 2 plus 3 plus 4 will be n. N is our 4. 4 plus 1, 5, divided by 2. Then you can divide numerator and denominator both by 2, and I have 2, which is 10. So the fourth number will be 10. And what did we say about the eighth number? We knew that it is 36, but let's check eighth number. The eighth number will be 1 plus 2 plus all the way to 8. That can be found using this rule too. So 8 times 8 plus 1, which is 9, divided by 2. And of course, 2 and 8 both are divisible by 2, and we have 4 times 9, 36. Yes, it works, right? Then what could be the 120? So if we add all the way to 120, what that will be? 120 times 121 divided by 2, which is 60 times 121. So we have 6 times 1, 6, 6 times 2, 12, 6 times 1, 6. So 7,260. So that works. And we could generalize it, right? So from specific case, we found the rule and we generalize it. Is that inductive reasoning or deductive reasoning? From specific case to generalize. Inductive or deductive? How many of you think it's inductive? Inductive. Specific case to generalize numbers. It is inductive. Very good. Okay. So we can find the rule like that. Okay. Then we can use this with to solve this problem too. So where is it? It's 72 triangular numbers. We can think about n times n plus 1 divided by 2 is 72. It is possible or not? If it is possible, it is triangular number. If it's not, it is not a triangular number. But let's check. So if I multiply 2 on both sides, what happens? I have n times n plus 1, and I have 72 times 2, which is what? 144. But if you think about the factors of 144 to make it, as 2 factors where one is greater than the other. You can't, because that 144 is 12 times 12. It's not like 12 times 13 or 11 times 12. It's in between. So you cannot have n times n plus 1. That's why it is not a triangular number. How about 120? Can we write that similarly? N times n plus 1 divided by 2 is 120. Let's check. I can multiply both sides by 2. So ignoring all that, erase it. I'm working on this problem here, okay? I'm multiplying 2 on both sides. What do I get? 240. So I'm gonna find the factors for 240 to find one is greater than the other. So I see this is 24 times 10. Of course, the difference is not 1. So I'm gonna think about a different way. If I keep doing that, it will be 2 times 12. And this is 2 times 5. And 2 times 6. And 6 can be written as 2 times 3. So I use prime factorization. Prime factorization means I'm using only the prime numbers to find the factors. Okay? So by manipulating somehow, I need to find the difference between one factor and the other, just one. Do you have any idea? What's 2 times 2 times 2 times 2? 2 times 2 times 2 times 2. 16. 3 times 5? 15. 16 and 15, the difference is only 1, just like this, right? So I can say this is the same as 16 times 15. So by n is 15. So 240 is a triangular number. Specifically, it's 15th number. Does it make sense? So with this rule, we can find two things. This is a triangular number, and it is 15th number. 15th triangular number. Okay? Yes.
So like if it says like find 120 and then you just put it in that equation what we just did and then find it from there.
Yes, we can do that. So let's have another practice. So pick any number to see whether it is a triangular number or not. Just give me any big number. How about this? 2,400. Is this a triangular number? You don't want to add 1 to all the way something to find 2,400. It's way too much. We don't want to do that. So let's consider that's a triangular number. Then we can use this is n times n plus 1 over 2. And see if you can have any combination of the factors like that. I will give you about 30 seconds to do that. You found them? Okay, so if we continue to do that, we can multiply 2 on both sides, right? So we have 4,800. And you can cancel this out. That is n times n plus 1. Because it's a big number, it's kind of hard to find that combination too, but we can try, right? So if you use prime factorization, the easiest way is 48 times 100 and go from there, right? So 48, it is divisible by 2 because it's even number, and 2 times 1 makes 48, 24, and 24 is also even number, so continue. 2 times 6 times 3, and 100. And times 10, not prime yet, but 2 and 5 makes 10, and 2 and 5 makes 10. So we can find this whole thing as 4,800 is equal to 2 to the what power? 1, 2, 3, 4, 5, 6. And we have 3. And we have 5 squared. Did anybody find any combination to make this number with 2 numbers multiplication? One is greater than the other. What's 2 to the 6th power? 64? Okay, 64. That's 25. 3 times 25, 75. So it's now 1, difference of 1. So you need to consider the combination to make it closer to n times n plus 1. But it doesn't work because we just got 75, 64 and 75. If you have 25 times 3 is 75, right? So that's one combination with big numbers. We don't want to do 2 times the rest of it. It doesn't make sense, right? How about making this a little bit bigger? So think about it. For now, I use only 2 to the 6th power, and I have 3 times 5 squared. And the difference between these two numbers is 11, which is really big, right? The difference is 11. The next combination that I think to make this one a little bit bigger and this one smaller will be what? 64 times 3. If I do 64 times 5, it will be way too big. So next combination that I can think about is combining these two together and separate this. So next combination will be 64 times 3, which is 12, 18, so 192 times 25. The difference is getting even bigger. You cannot have any factor that makes n times n plus 1 for this one. So it is not a triangular number. Okay? So you can think about that. I think that's the last problem that we want to go over. And for next Monday and Wednesday, we are going to meet in the computer lab. If you don't know the computer lab, it's right across this hallway. There's 142, room number 142. 142, that's computer lab. We will meet there for chapter 1 review and the test. Okay, so on Monday, we're gonna work on chapter 1 review. We already did some. This will be individual work. I will let you do your work, and if you need any help, you can just raise your hand and I can go and help you. That's what we're gonna do on Monday. On Wednesday, we meet again in the computer lab for you to take the test. Okay? Does it sound good? Okay, so I will meet you on Monday and Wednesday at the computer lab. I will send you guys an email for that too. And the homework, only problem solving homework is due by Monday.
So I was victim successful before, and then I got a note from
Ah,
my
you are the
boss.
ambassador.
Yeah.
Okay, that's great.
I had her write a note.
Okay, thank you. Yeah, I was wondering.